So the second thing nhưng mà nếu để cho
Good evening, everyone. Good afternoon. Can you hear me? If you can hear me, you can just confirm in the chat and we proceed with the lesson. Okay, so my name is Ben Wycliffe Mogalu. I'm going to be taking you through NoSQL databases. We're going to look at a number of things, look at how they compare with SQL databases, and also work with MongoDB, which is one type of NoSQL databases. So meanwhile, you can, if possible, you can let your classmates know that the class is on, maybe through the class WhatsApp group, but we shall begin shortly. So I'll share my screen and we begin. You confirm if you can see the screen. So today we're going to be looking at we're going to be comparing non-relational databases and relational databases. These tutorials are mainly focusing on non-relational databases, call them NoSQL databases. But we shall begin with looking at how they compare the two kinds of databases. So starting with relational databases, relational databases, call them SQL databases. They can be accessed with a programming language called SQL, structured query language, and they were developed in the 1970s with a major focus on reducing data duplication, because in the 70s, storage was a little expensive as compared to currently. So then engineers were looking for ways to minimize the amount of storage required to store data. So the SQL databases were developed with this idea in mind. And these databases are also organized in tables with data, with discrete data. So you have tables, and the tables have columns, and the columns have discrete data. The data is exact, like you can't have one column having different types of data. It's call of names takes a string character type. So that explains the discrete nature of data here. And the tables with the relational databases are related with each other, hence the name relation. And how does the relationships come about? They're created through keys. So keys are used to create relationships. And I assume that you've looked at this previously with SQL databases, and you know what a primary key and a foreign key is. So that's like a brief summary of what a relational database is. And some of the disadvantages of relational databases are the fact that the designing of tables is really complex. You need to, before you create your relational database, you need to understand exactly what your database should look like and exactly how your data will be stored. So if your application is a big one, then the design of that table is going to be a complex one. Someone saying something? Okay, let's proceed. Another disadvantage is that relational databases require really highly skilled database administrators to manage. And then they require wholesale operations. If you wanted to make an update in your SQL database, you have to update. Like for example, if you have a table already created and you want to add another call, you have to. If you're trying to update maybe one row within a table, SQL databases don't give you the capacity to just do this for one row. If you want to do it for one row in a table, you'll have to do it for all the rows in the table. So it requires also operations, making them complex databases. And the last disadvantage we have here is that they require complex join queries, because typically SQL databases are normalized. So you have very many tables that are related to each other. In most cases, you're going to find yourself needing to make a query that extracts data from a number of tables, like 3 tables. So as a result, you'd have to write a complex query, typically join query. You join this data from the different tables. Some of the examples of relational databases, we have Oracle, we have MySQL, and we have the Microsoft SQL Server, and then PostgreSQL. PostgreSQL is like very common in production. Most applications use this in production. Let's proceed to non-relational databases. You can also, they can be called non-SQL or not only SQL databases. So implying that your database could exist without any SQL programming language, or at some point you would have some SQL, but not only SQL. Now, these ones were developed in the 2000s with focus on scaling and faster queries. So yeah, you know, with SQL databases, we've seen that they have very often you're required to write very complex queries during operations to extract data from a number of tables, and that is like downside. So this is one of the things that NoSQL databases were developed to get done with. And another characteristic here is that SQL databases do not have a predefined schema. So basically with SQL databases, you can just start creating your database. Unlike with NoSQL databases, you can just create a database. Just put data together. Unlike with SQL databases, where it is required to understand how exactly your database will look like, and design the tables before you actually create the database. Here you can just go on and add data. It just scales out and out and out. Don't need to worry about what your structure is initially. And then another characteristic, which is also a disadvantage, or rather an advantage, is that SQL databases can store different types of data in the same collection. We shall see what a collection is in the future. Now, some of the examples of NoSQL databases they're not actually examples, they're types. You can call them types of SQL databases or NoSQL database models. We have document databases, key value stores, wide column stores, and graph databases. We're going to look at each one of them in detail. Lawrence, please mute your microphone. Lawrence, could you please mute your microphone? Okay, sorry about that. Let's proceed. I hope Lawrence has muted his microphone. So we'll start with document stores. Now, document stores store data in documents similar to JSON objects. I hope you're familiar with what a JSON object looks like. It's basically JavaScript object notation. Now, each document contains field and value pairs, just like a normal data structure in a typical programming language. So the values can be represented by any type literally. You can have strings, you can have numbers, you can have arrays, you can have another object, you can have a Boolean, etc. The structure for document stores typically aligns with what software developers work with. Again, if you're a JavaScript developer or Java developer, if you look at the Python developers, the dictionary, JavaScript is typically a JavaScript object. So this notation is really similar to what traditionally developers work with. So it makes it a bonus for them. So because of their variety of field value types and powerful query languages, document databases are great for a wide variety of use cases. They can generally be classified as general purpose databases, general purpose NoSQL databases, because of their inherent, the way they are created, the fact that they take on that document structure that is typical in any programming language. And some of the examples of document stores are MongoDB and the Couchbase databases. So we shall be using MongoDB in this course for practical work. Yeah, but Couchbase is another example of a NoSQL document store or NoSQL document model. Then another type of NoSQL database is a key value store. So these ones simply have keys and values for each item you store in the database. And if you want to retrieve a value from your database, you just refer to the key. You refer to the key and get the value that is assigned to that key. These ones are very simple to query, and their structure typically aligns with what developers work with, just like the document databases. However, these ones are great for use cases where you need to store large amounts of data, but you don't need to perform complex queries to retrieve it. So take note of that. If you ever want to use the key value store type, NoSQL database, you need to ensure that you won't need to perform any complex queries. Otherwise, it might not be suitable for your needs. And some of the common use cases include storing user preferences or caching. And the examples here we have Redis and DynamoDB for key value stores. And we proceed to wide column stores. These ones store data in tables, rows, and dynamic columns. So it sounds like they are pretty close to SQL databases because we're talking about tables and rows. But note that here we have dynamic columns. So unlike SQL databases, each row is not required to have the same columns. So you can have a table where some rows don't have miss out on some data, and that's no problem, which is not the case with the SQL databases. And then many people in the databases world consider these ones to be two-dimensional key value databases. And these databases are great for when you need to store large amounts of data, and you can predict what your query patterns will be. So if you have like an application that's going to store a lot of data, and you can predict what your query patterns will be, then this is a very, very good database to use. So they are commonly used for storing Internet of Things data and user profile data. Some of the examples we have here are the famous Cassandra. This one you find that most social media companies use it. Instagram typically runs on Cassandra, and some part of Facebook uses Cassandra. And then another example is the Apache HBase. And you can see that we say one of the most common use cases is user profile data, and hence that's why social media companies like to use this Cassandra database because they are NoSQL option. So let's proceed. And lastly, we have graph databases. Now these ones, just like graphs, in graphs you have nodes and edges. These ones store data in nodes and edges. So the nodes store the information, can be about people, places, things, or whatever case it is. And then the edges store information about the relationships between the nodes. Now this type of NoSQL database is suitable for cases where you need to store, you need to traverse relationships to look for patterns, such as social networks or fraud detection and recommendation engines. And some of the examples here are Neo4j and Genus Graph. We shall look at the advantages of NoSQL databases. Number one, they have flexible data models, and we've looked at this. They allow for change of database as requirements change. So you can iterate quickly and continuously integrate new features into your application. As I said, here if you're working with a NoSQL database, you don't need to, it's good to have a schema, and it's really important that you have a schema for your application, but the rules here are not rigid. Like you can really take any direction. Your application the database can scale out with the application. It's flexible. And then they require horizontal scaling. Now, what horizontal scaling means is if you have two servers, there are two types of scaling. There's horizontal scaling and vertical scaling. Now, for vertical scaling, let me explain it this way. You have a server, it's hosting your database, and your database grows. Like you have very many users that are adding information into your database, and then you realize that your server cannot hold this information anymore. With vertical scaling, you would have to get a newer, bigger server and do away with the old one. And this is usually very, very expensive because as the specs increase, the device becomes more expensive. Now, for horizontal scaling, when your server can't hold the database anymore, like it's not sufficient, you don't have to do away with what you currently have, but rather you can get another smaller or cheaper server and just connect it with the one you currently have. So you just, in a layman's language, it's like having a network of servers, like a distributed network of servers, they work with each other. So you can add cheaper commodity servers whenever you need to. That is with NoSQL databases. They don't require vertical scaling, which is a requirement with SQL databases. If your server can't do it anymore, you'll need to do vertical scaling. But here, you can do horizontal scaling. You basically just get another server, smaller server, and yeah, you'll be good to go. Then another advantage is fast queries. So data is stored in a way that it is optimized for queries. and queries do not typically require joins, as is the case with SQL stores. And yeah, we've looked at this, that NoSQL databases were primarily created to make it possible to implement faster queries. And then lastly, and the advantages, it is easy for software developers. We've seen this again. Some NoSQL databases like MongoDB map their data structures to those of popular programming languages, as we shall see, and as we've discussed before, that the document databases, or most SQL databases, take on they store data in a notation that is very, very similar to a data structure in the most popular programming languages. So this makes it easier for software developers because they typically will be applying the same techniques they apply usually when they're doing their programming. So that's another bonus when it comes to NoSQL databases. Some of the disadvantages we have here is that the NoSQL databases do not support ACID operations. I assume that you've looked at this previously, but ACID operations, that is atomicity, consistency, isolation, and durability, are a requirement for secure transactions in your database. So these with NoSQL databases, they are not supported across multiple documents. But with appropriate design, you can have single record atomicity. And this can be acceptable for a number of applications, but still many applications require ACID to have more secure transactions within your database. And then another disadvantage with NoSQL databases is that they are larger than SQL databases. So NoSQL databases focus on optimized queries and neglect reduction of data duplication. But you know, with SQL databases, we typically normalize the database to try and reduce duplication, and as a result, you reduce the data that can amount in your database, which is not looked at when you're working with NoSQL databases. All we focus, when they were created, the focus was on getting faster queries, and they completely neglect duplication. So as a result, you can have a lot of information piling up in your database. But storage is currently so cheap, so most people in the database world consider this to be a minor drawback. And also some NoSQL databases support compression, so it might not be a big deal. Then lastly, under disadvantages, NoSQL databases may not achieve all your use cases depending on what you're using. So as we've seen that, as we were looking at the stores, the database stores, the types of NoSQL databases, we saw that most of them are typically suitable in specific use cases. So most of them are suitable for different use cases. And when selecting your NoSQL database, you should consider what your use case will be. If you're not sure, then a general purpose database like MongoDB will be a better option. All right, let's proceed. So we shall go through a summarized comparison between these two. In terms of the data storage model, we've seen that SQL databases use tables, rows and columns. And then for NoSQL databases, that depends on what your database store type is. If it's a document database, then you have JSON documents. If it's a key value, you have key value pairs. If it's a wide column, you have tables with rows and dynamic columns. Note that creates a difference between them and SQL databases. And then lastly, with graph stores, you have nodes and edges. Then in terms of development history, we saw that SQL databases were developed in the 1970s and the focus was on reducing data duplication. Whereas for NoSQL databases, they were developed in the 2000s with the focus on scaling and allowing for rapid application change driven by Agile and DevOps practices. And then in terms of schemas, SQL databases are really, really rigid. You have to know what you're doing. Then for NoSQL databases, it's flexible. You can just develop. The database would scale out. Then primary purpose, SQL databases are general purpose databases. Then if you look at NoSQL databases, this again depends on what type of store you're using. If you have document store type MongoDB database, then that's a general purpose one. You can literally use it for anything. Then for key value pairs, you should use this when you have large amounts of data with simple lookup queries. Then wide column, you should use this when you have large amounts of data with predictable query patterns. Then for graph stores, that's suitable when you're analyzing and traversing relationships between connected data. Then in terms of scaling, again, we've discussed this. SQL databases require vertical scaling. I want to explain this again. And NoSQL databases require horizontal scaling. In terms of ACID transactions, for SQL databases, it is supported. But for NoSQL databases, most do not support. However, some, like MongoDB, which we're going to look at, do support ACID transactions. And then in terms of joins, they are typically required in SQL databases. You can't avoid them. You'll have to do joins. Then in NoSQL databases, no need. That is the end of our first tutorial. We're going to look at the next tutorial where we introduce MongoDB. Any questions so far?
So thanks, Ben. Can you hear me?
Yes, I can hear you.
Right. So there were, I was keeping track of the chat window, and I saw people would like to know a little bit more about JSON. First is a question about the schema. I know we handled this during the class, but maybe you can go over that, what you mean by schema in terms of this NoSQL databases. And then a brief explanation on JSON objects. And I think the other is to briefly go over the ACID principles, which we have actually not covered yet in class. Those are the three queries that I've seen. Someone is also asking whether the PDF and PowerPoint will be made available, and the answer is yes. We'll make the video, the PowerPoints, and the details of the tutorials available as well. Okay, thank you. Back to you, Ben.
Well, we are going to look at the schema and JSON objects in the next tutorial. And then for ACID transactions, let that be an assignment for you guys.
Good one. Okay, please carry on, Ben. And someone is asking for a cut. Yeah, I'm going to be announcing the date of the cut this week. So I see someone has their hand up or not. Isaac, you can speak. Isaac, your hand is up. Do you want to say something? If so, please go ahead.
Yeah, so I want our tutor today to make a clarification about MongoDB, because when he was explaining about how MongoDB works, he talked about MongoDB using JSON, but yeah, from some research we've done, if you look at the docs, they actually restructured JSON to form some other language, okay, not language, but another version of JSON they call Bison. So is that really correct, or still the same JSON? Because okay, the syntax is similar if you look at it, but yeah, they give them different names. Though this one is kind of more binary encoded, so I think it's more powerful. Yeah, there is that confusion there. I don't know which one we should go with.
Oh yeah, it's not what they use in MongoDB is not JSON. but it looks like JSON. That's the whole point. It's actually BSON, it's something different, but it takes on the structure, and I've been saying this, it takes on the structure of the typical object in the most popular programming languages, and that makes it easier for developers. But it's not exactly JSON. It just looks like JSON. I've answered your question.
Okay, great, Isaac. I don't know if your hand is still up or you're happy with the answer. Yeah, but indeed you're correct. Although Ben had also hinted that it just looks like JSON and is convenient for representation, but yeah. But I guess you're going to see more about that as the tutorial, the hands-on continues.
Okay, so let's proceed with MongoDB.
Before you proceed, someone is asking where wide column stores are used in real life.
In real life, I think I again talked about this. They are used in applications where you have a lot of data, but you can predict your queries. And we gave one of the examples as user profiles. And I told you that one of the examples of wide column stores is Cassandra. And Cassandra is popular in social media companies. And I told you that Instagram runs on Cassandra. Why? Because there's a lot of data and it's a user profile. You can pretty much predict what your queries will be. I hope I've answered your question.
So yeah, I mean, just to add a little bit about that is that the point is if your data is in such a way that you have a lot of fields related to an entity, which is the case if you're looking at profile of individuals in the social media context, then it might not be very wise in terms of query optimization to go with the row-wise at least underlying implementation, because then you'll have complex queries, and this will take very long for you to query and get back the data. And that is why you see that in such settings there are these column-based databases become more popular, because then the data itself, the underlying storage is stored in a column format, which is convenient for, say, pulling out all the fields of an entity, of an entry at the same time. Yeah, and again, you can go and read a little bit more about this if you're very interested in wide column stores.
Okay, are there any more questions, or we proceed? Okay, let us proceed with MongoDB. So MongoDB is a famous one among NoSQL databases, and its name Mongo originates from the word humongous, and humongous means lots and lots of information. So because it stores a lot of data, the name Mongo came from that word humongous. And Mongo is particularly built for large-scale applications, though you can use it for smaller scale applications, but it was designed for large-scale applications to store lots and lots of data. Now, MongoDB stores data in documents. A record in MongoDB is a document, and it is basically a data structure composed of field and value pairs. And this field and value pair structure is very similar to JSON. I've been talking about JSON. So if you look at this document here, this is what JSON data looks like. You basically have a key and its value, a key and its value. So what MongoDB uses at the back end of it, it's Bison, it's their own language, but it looks like JSON. So just to highlight what the point that Lawrence raised during the first tutorial. So the values may include other documents. You can have an array. For example, we have an array here. You can have an array of documents, but it's basically just like a data structure. That is how data is stored in MongoDB. Every record is like a data structure, something like this, similar to JSON, key value pairs. Looking at data models, you can have two kinds of data models. And the first one is the embedded data model, if you're storing your data in a MongoDB database. So for the embedded data model, what it does, it embeds all the related data in a single document. So this data model can also be known as a denormalized data model. If you look at this example we have here, we have an employee object, call it document or record. So if you look at it, in here we have the biography details, which have it has the first name, last name, and date of birth. Then you have the contact, email and phone, you have the address. Now these are all objects. They can be objects on their own. Call them objects, or they can be documents on their own, because a document typically is an object. Whenever you have these curly braces and key value pairs, that can be a document in MongoDB. But what the embedded data model does, it gets all the related documents and it embeds them within one document. So for example, you'll have a database of employees, and each employee record, call it object, will look something like this. So you have an ID, employee ID, then you have the subdocument, bio details, you have the contact, also a subdocument, you have the address, also a subdocument. And these documents can always be navigated using the dot notation. Yeah, I think I've explained enough regarding the embedded data model. So let's see the normalized data model. So the normalized data model is just like the opposite of the embedded data model, and it takes on the SQL way of doing things. It normalizes the document, so it just creates relationships between each subdocument to the main document. It refers subdocuments to the original document. So if you look at these documents, address, contact, and bio details, in the previous slide, we had all of them embedded in one document, the employee document. But in this case, they are separated, they stand alone as independent documents. But each document has an employee ID, key, and value. This is like, in quotes, it's like a foreign key that refers this back to the employee ID, rather the employee object. So it kind of creates a relationship. So if you have an employee object and its ID, you can always extract the other related objects, documents called, because I'll keep on interchanging the words documents and objects. Please bear with me. Yeah, but as long as you have the main document here and these other documents have been referred to the main document with this key of the employee ID, if you look at the address and the contact and the bio details, then you can always be able to retrieve this data too. So this is these are the two data models. We have the embedded one and the normalized one. So this right here is the SQL equivalent to this document. Here we had an embedded document. Then we have a normalized data model that creates relationships between all the subdocuments and makes them independent. So this typically is trying to do what is done in SQL databases, and I wouldn't advise you to always do this, but it's just something that is also possible with MongoDB. So you know you can do things the SQL way. So if you look at this table, we have the employee ID and the primary key for every entry in the table. It's the same thing we have here. We have the ID and employee ID. Then we have another table, address, and it has the employee ID as a foreign key. Same thing here. You have employee ID. It's like in quotes the foreign key, because this is not actually SQL. Yeah, but it takes on that data model that is typical with SQL databases. So you know it's possible with MongoDB. We shall proceed. So next we're looking at collections. Now, what a collection is, a collection stores documents. So MongoDB uses collections to store documents. Now, for example, yeah, as you can see here, it's analogous to tables in relational databases. So in relational databases, where you have a table, maybe let me say of users, in MongoDB, you'll have a collection of users. So let me say this is our collection. It's analogous to a table. Now, for where you have a row in a table of users with a SQL database, here in MongoDB, you have a document. So a collection has very many documents, and each document represents a unit of data within your database. I hope that makes sense. So collections, just map them to tables. Let's proceed. We have an example. We're going to be looking at schemas. We have a blog website schema, and we're going to compare a typical relational database management system schema and a MongoDB schema. What a schema is just, in a layman language, it's just a representation of your database. Before you actually go ahead and create your database, you can have a schema which represents what your database will look like. So what we have here is a class diagram of blog post application. So you have every box here represents a table. Now this is for the SQL database. So if you look at the post, we have the ID, primary key, that's title, description, URL likes, and then the relationship, you can have 0 to many comments in your post. And each post has a primary key, then it has a foreign key, post ID, which maps it back to the post table. Then it has the username, the message, what the comment was, the date and time, and then the likes. Then on this side, we have a tag list. It has an ID of its own, then it has the post ID, which maps it back to the post table, and then the tag. So this is a schema of a pretty normalized SQL database. This is what it looks like. Remember, schema is just a representation of your database, no complex terminologies. Now we have a schema of a MongoDB database. So this schema is taking on still the object notation format. So it's modeled with embedded model type. So you have the subdoc here where we have the comments as a different table and the tag list as a different table. This is taking on the normalized modeling type. This is taking on the embedded modeling type, which is trivial which you should use if you're using MongoDB really. So you see we have the comments being embedded in here as an array of objects, because one post can have more than one comment. So you have we have an object representing a comment. And then for the tags, you see here we had to create a different table with an ID and a foreign key, rather with a primary key and foreign key. And what we really needed was just the tag name really. So here we do away with all that complex relationships, and we just embed the array in there in the document, and it has the tags. You don't need to create relationships for each individual tag. You just embed it there in the document. And yeah, if you're a software developer, you would really appreciate the beauty of this document structure that comes along with MongoDB. It will really make your life easier, because this is the structure you literally look at all the time. So you can get along quite easily with the MongoDB database. So some of the considerations, things you should consider while designing your schema, you should always based on user requirements. So if you're designing the schema for a system, before you begin to design the schema, you must make sure that you understand what the system is all about and have the requirements in check. Then another consideration here is embed documents of objects that will be used together into one. Yeah. As we've always tried to use the embedded data model. Otherwise, you'll just end up doing things the SQL way, and you might find yourself having to do joins, which is typically something that was intended to be done away while creating NoSQL databases. So if you try to use the normalized data model with MongoDB, you might find yourself in a position where you have to do joins, doing things the SQL way. Then another consideration is separate objects that will not be used together, but make sure to avoid joins. So yeah, you can separate objects that look like they will never be used together, but try to avoid doing joins. And then try to optimize your schema for the most common use cases. I don't know how to explain this. Basically, if you really look through your user requirements, you would know what are the most common requests the database will be receiving, the most common queries. So then you can try to optimize your schema, because this is really, really flexible. You can always try to optimize your object schema in such a way that it suits the most frequent queries that will be received. And then don't worry about data duplication. You can duplicate data, because nowadays storage is really cheaper than compute time. So some of the key features of MongoDB is that it has a very high performance and a rich query language. It's highly available, and it gives you horizontal scaling, which is a big plus. And then it has support for multiple storage engines. Basically, there are different types of storage engines, and if you're interested in this, you can read more about it, about the storage engines, but there's a possibility of choosing a storage engine you desire. So if you're interested, you can go and read more about storage engines. We shall not go deep into this as a requirement of this course. Then lastly, let's look at how MongoDB is installed. So I think I will share a setup file such that you guys get to use exactly what I'll be using to avoid. I'll just share the setup file, but you can as well go to the MongoDB website and download MongoDB. So the first step would be downloading MongoDB. And again, when you receive these slides, the steps are pretty easy. You just follow this. You run the installer, and you choose under setup type, you choose complete. When you choose complete, the next screen will have service configuration. Just go with the default settings, don't change anything. And then you can decide to install MongoDB Campus. MongoDB Campus is like a graphical user interface to your MongoDB database, but it's optional, really, you can skip it. But if you decide to install MongoDB Campus, it requires internet connection. Then, yeah, when you're ready, you install your MongoDB. So this is something that should be pretty easy to do. So I'll just add the setup file to a drive and share it, maybe with the class rep, and you guys can download it. It's not that heavy. Or if you wish, you can go and look for it yourself, but there are various versions, and I think it's wiser to just go with what I'm going to share. I assume that there are no Linux users or Mac users, but if they are there for you guys, you can go to the MongoDB documentation, and the commands are pretty simple that are required for installing MongoDB on your Linux. It's pretty easy. And I assume that since you're using Linux, it shouldn't be a problem with you if you're using Linux. Then after installing your MongoDB on your PC, you just run this. You just type this, it should be in quotes, and you'll have access to your MongoDB shell. So yeah, you guys will get to install MongoDB when you get back. But for now, I'm just going to quickly demonstrate how you can start the Mongo shell and make a few commands. We're just going to look at this for today, and the next lecture we shall be doing more queries MongoDB. So just a moment. Can you see that? Someone confirm?
Yes.
Okay, great. So yeah, if you after installing your MongoDB, after following those steps that are in the previous slides, it should be very, very easy. You just type that command in there, and when you enter, you'll have access to the MongoDB shell. And the first thing, before you even look at what I have in my slides, you should always try to, there's always help that comes along. So you can, I hope you've noted that command, it's db.help. There are lots of things here. You can explore them on your own as part of being an engineer or a software developer or anything of that kind, is finding out things on your own. What I give you here is like 5%. Most of it, you have to acquire it on your own. So the help command is there. You can check out, there's a number of things. For example, let me go up here and see what we have. You have DB stats. But anyway, let's just proceed with what I have in my slides. You can check out that in your free time after installing MongoDB. So if you want to create a database, you basically just use the keyword use. So the current DB using originally immediately after installing your MongoDB and running the MongoDB shell, it comes with the test database open. But you can always create another database using the keyword use. So maybe you can say use users. So now, is that font size sufficient for you guys? Can you guys see what's on my screen? Someone give me feedback.
Yeah, you can see your cursor.
Okay, so I'll switch to users. So if I type DB again, you see that I'm in users, but just using the keyword use, then the database name. Yes, it initiates the database, but it doesn't save the database, not until you actually add some data to the database. So if you just say use, then your database name, yes, the database will be initiated, but it won't be saved, not until you add some data to that database. So help db.help. See, I'm also using help. I'm looking for some commands. Yeah, show dbs. So if you type show dbs, you can see the databases that you have. Currently, I have admin config. This one's come by default, local. This new DB, and then the test also comes by default. But guess what? If I type DB, I'm in the user's database, but it's not here. Why? Because it hasn't been actually created yet. It has been initiated, but it hasn't been created yet. Why? Because I haven't added any data. So if you want to create that database, you must add some data in it. So I'm going to use this. Where is it? This command here to create a collection, db. So why am I doing this? I want you guys to see that most of the stuff you need, you can find it here if you know how to use the help function. So db.create. Also note that we use a camel casing. If you look at most of the commands, it's camel casing. The first character is lowercase for the first word, then the rest of the words, for each new word, the first character is uppercase. That is what I mean by camel casing. So create collection. So I'm going to create a collection of maybe, let me call it students. Yes, so a collection has been created. So if I say show collections, remember my DB is users. If I say show collections, see, I have students now. I've created a students collection. If I say show DBs, I have users now. Why? Because I've added a collection. Adding a collection is like adding data to your database. So now my database has been created. I hope that is clear. Going back to the slide, one of the ways you can create a collection is what I've just shown you here, using the command db.create collection, then the name of the collection. Another way is just using the collection name, the name of the collection that you want to create in a command that adds data to your database, as you see here. So I have db.new collection is the collection name, then insert one. So if I run this command in MongoDB, if the collection doesn't currently exist in my database, the current database, MongoDB will create a new collection. Same applies to databases. If you say use and the name of the database is for a database that already exists, MongoDB will activate that already existing database. But if it doesn't already exist, it initiates a new database, which it then saves after you adding some data or creating a collection in that database. I hope we are together. So I'm just going to demonstrate these two. So I'll say DB. So my DB is still users. I'll say DB dot maybe tutors dot insert one. So I'm inserting, insert one means, again, you guys will explore these commands. Insert one means just insert one document in a collection. So I'm inserting a document. Remember our document takes on that syntax of JSON, curly braces, key value pairs. So I'll say tutors name, then. So yeah, it has added that. Remember, before this command, we did not have a collection, tutors. The only collection we had when I asked the shell to show collections was students. But if I show collections again, now I have tutors too. Okay. Then, yeah, I think we've looked at pretty much what is here. So you see the database is created when you first store data. You have clarified that. Then if you want to retrieve all the documents in an existing collection, you can just use this command. You specify db get collection, the collection name, then find. So find can typically take in filter parameters, which is like an object that specifies, it adds filters. It's things that the shell bases, the engine bases on to extract data from the database, but we shall look at that later. But for now, just know if you add find at the end of it, it should retrieve all the data in your collection. So we'll just try that on the tutors collection. So I'll say db.get collection tutors find. So it returns this. So also notice this, that when we're creating a document in MongoDB, we don't need to add an ID, but rather MongoDB generates the ID automatically for us. Because remember, when I was creating this document, I just inserted a document with a key value pair name and the name value pair. But what I've received when I extracted the data from the document, you see I have an ID there. Yeah, that's going to be it for today. In the next lecture, we shall dive deeper into queries with MongoDB and also write a basic Python application that uses MongoDB. Otherwise, thank you.
All right, thanks a lot, Ben. I do not know if there are any questions related to this or to the course in general that that you'd like to ask at this moment. Right, it looks like there are no questions. So what I'm going to do is I'm going to share the content, the slides from today, and yeah, you can have a crack at MongoDB and go through the concepts of NoSQL databases on your own. I also hope the SQL exercises are going well. I essentially posted the last walkthroughs for SQL on DataCamp. They are all fairly easy, like I can tell. I think there's a few folks who have already worked through all 4 of the exercises. So I think the sooner you wrap this up, the better. By the end of the week, I would have announced the date for the first cut, and I think I'll also post the your practical hands-on group exercise that will kind of serve as a capstone for the practical aspects of the course. Otherwise, if there are no further questions, if there are no comments, I wish you all a good evening for now. And thanks, Ben, for spending the time to help out. All right then. Cheers.